Today is what we call Sunday learning. This is for the first time that we are doing it on Sunday. Gopakumar, myself, just debating with should we do it on Sunday? Sunday is supposed to be in a relaxed day with family and all that. And we thought, why not? This is something, if you want to learn, when you relax, you can learn something better. While we in office or Saturday of a week and weekdays, you're under pressure. So I'm surprised, we got over 800 participants for this program. Maybe the subject is quite interesting. Maybe the speaker, Mr. Gopakumar, is becoming now international speaker. He was saying that immediately after this, you need to pack up and rush to Philippines. He was there in South Africa last month. Now he's in Philippines. I don't know. As we keep doing this seminar, I think he'll be in demand world over by every country in the world. That's very nice to see that we're becoming quite popular when it comes to electrical safety. And I just want to all my participants here. This is what we did in the entire year. You look at the various subjects we started. Almost we are going to celebrate one. Yeah, this is now second year. We have done almost 25 webinar on various electrical safety. Look at this. We're looking at building fire, why it's happening. Everybody blame that electrical short circuit is the cause for the fire. So whenever there is a fire, all attention goes to electrical safety. Yeah. So this is something that we thought, okay, let's understand what are the best practices in installation. Are we following any standard? There are Indian standard, there are IEC standard. How much are we ensuring that our installations is as per the standard? I'm sure Gopakumar will throw a lot of lights on how far we are when compared to the rest of the country, how far we are following, whether it is electrical audit, whether electrical installation, whether it is earthing. How are we? Where are we? What do we do? What kind of professionals that we engage in putting up our electrical design and installations? So there's something. My name is Dominic. I've been involved in fire and security industry now for over 18 years, 35 years in the fire industry. And we've been doing almost 125 webinar last 1.5 year with the support of CAPE. We would have tested over 25,000 people. That's something that we feel proud, and we have done some kind of free knowledge. These are not paid registrations or free knowledge to those who thinks safety should be way of life. To become safety as a way of life, whether at home, whether a building, anything, we must look at everything, whether how my building is built, whether my occupants are safe. Entire series, 25 series, is supported by Cape Electric. Okay, though it is non-profit programs, Cape has been advocating various best practices, standards, audits, products, and I would like to introduce who is Cape Electric. They started in 1998. Surge protection devices were new in India when Cape installed first SPDs for protecting industrial electronic system. DC combiner solution for solar PV were unknown once when Cape delivered outdoor DC panel in 2002. In 2004, technical seminar on lightning protection not only helped the industries in solving a failure-related lightning, surges, and earthing, but gave in-depth knowledge about international standard. That's a big credit to Cape. In 2016, TNS systems with PME for industrial earthing without earth electrodes in soil, carrying safety and earthing a level above the existing practices. In 2019, global earthing system were interconnecting EHV and HV and LV and ELV system with large industrial and commercial installation and smart cities. In 2022, they launched Solve, a digital platform as a knowledge and process partner to ensure safe operation of low voltage electricity. That's called Solve, is introduced. Leading the market with the right solution is Cape Moto, and the team in Cape Electric are continuously trained to provide end-to-end solution from design to implementation rather than selling a product for the customer need. No need of much of introduction about Gopa Kumar. As I said, he is now an international speaker demanded in every country. But however, it's my duty as a host to introduce. Gopa Kumar is an electrical engineer, managing director of Cape Electric. He's having more than 27 years of experience in electrical safety, lighting protection, EMI and EMC, etc. He carried out more than 100 site studies on failure analysis of electronic equipment and hundreds of electrical accident analysis, including various fire accident from electricity, and conduct over 1,000 training programs in various countries on the subject of his expertise. He is a member of various standard, IEC standard, BAS standard, and also member of National Building Code. He has published articles about safety in various magazines and published the book, The Missing Link, the subject of electrical safety. Today, we are covering a very important subject. It's going to explain earthing and earth fault protection and lightning protection in solar PV application. Also, what are the recommendations given in the latest IEC standard? I'm sure all my friends who have taken a permission with your family to be listening for next 1.5 hours. And let's make this program more interactive. I would like to see good questions coming in, and we'll take a good question. Those may not be covered in this topic, but a good question related to this subject. Okay, do not divert the attention to any other subject. Let's put up the questions on related to this subject we are covering today. So we should end up by 12:30, and I look forward wonderful participation. God bless you all. Over to Mr. Gopakumar.
Thank you very much, Mr. Dominic. Let me share the screen. I hope the screen is visible, and now yes. It is in full screen.
No, yeah. Sir. Now it's full screen.
Yeah. Thank you.
Sir. Go ahead, sir.
So thank you very much, Mr. Dominic, for the good introduction. As usual, we have more than 200 participants today as well. I think it is crossing. It keep on increasing. 215, 216. Okay. Now. As you said, actually, I reached Chennai yesterday night. Yesterday, we had a nice seminar, electrical safety seminar in Nagpur, organized by the Institution of Engineers. There were, I think, about more than 140 participants were there. So I reached midnight, and today, immediately after this program, I have to leave to Philippines. So there is an IEC working group meeting from tomorrow onwards. Anyway, within this, so I will try to finish as quick as possible because of the time constraint. Let me switch off the camera. Today we are going to discuss about solar PV. As you are aware, this subject has been demanded by our participants for several occasions, but we were trying to skip because of the importance of the other subject. But anyway, today we are back with safety, earthing and lightning protection of solar PV. My experience with the solar PV, we started making solar combiner boxes during 2002. At that time, nobody knows solar PV, or solar PV was very, very limited. The market was opened up only after 2012 or 2013. We were making combiner boxes until 2012, but after 2012-13, we stopped, reduced making solar combiner boxes, and after 2015, we in fact stopped making solar combiner boxes due to some technical as well as commercial reasons. Anyway, today's program has nothing to do with our business. we are going to discuss about what is written in the standards about safety and how to implement or how to follow these particular requirements. We will be discussing about the standards 62584 design requirements, 63112, which is about earth fault protection in solar with respect to safety and functionality. Then 603647712, which is talking about low voltage electrical installation, particularly solar PV installation. Then, related standards, and the last one is the earthing and lightning protection of solar PV installation. Just as an introduction, you know very well that the solar PV, for example, for the engineer, the participants who are not familiar with solar PV, some of the terms which is used are sometimes it is called as array circuit, PV array, photovoltaic array circuit, application circuit. Sometime in the circuit, the solar PV is also used with batteries, often without batteries. There are different combinations. The names you can see here, sometime PV array circuit, DC bus circuit, battery circuit. These are some of the technical words explained in the standard. Sometimes once when we go deeper into the subject, it is important to understand and keep these wordings in mind. Otherwise, sometimes if I explain DC circuit and if you try to think it in a different way, it becomes very difficult. So PV array, it consists of a PV module, sometimes series combinations of PV module in order to attain certain operating voltage for the purpose of reducing the current. Then the PV string cables are there. There are OCPDs, overcurrent protective devices, isolators, and power conversion equipment. In the presentation, I will be using the name PCE, power conversion equipment, which is nothing but any electronic object which is accepting the DC and converting it into a DC or AC voltage. So here, one important subject which we should understand is nowadays the solar PV is DC side is operating with voltages up to the allowed voltage is 1500 volt DC, but for residential purpose, anything above rooftop maximum allowed is 1000 volt DC. If rooftop installation is operating with higher than 1000 volt DC, then of course the location must be limited to experts, or location must be limited to technicians. Normal people shall not go to those areas. Now, again, some more explanations. PV modules are connected in series, PV strings are made, then combiner boxes are there. These boxes are collecting the energy, which will normally contains fuses, SPDs, isolators, and so on. Finally, they are connected to the power conversion equipment. Some of the definitions also you can see here: PV overcurrent protection, PV string disconnector. All these are sometimes, it is written as if applicable. So it's very interesting to note that these are if applicable. I will explain it later. Let me skip some of these configurations, not very important for today's program. This, what you are seeing in the picture is a multiple parallel string with divided into sub-arrays. Each array is divided into sub-arrays. You can see these pictures again in the standards, whatever I have mentioned. Oh, I have so many pictures, one moment. Yeah, the first part with respect to safety is rooftop system. Maximum voltage allowed is 1000 volt DC. If more than 1000 volt DC is used, the access must be restricted to competent persons only. That means only the technicians only should go to that particular area. There are buildings nowadays with more than 1000 volt DC, but most of the time these are rooftop in large industrial areas, but industrial area rooftop only the technicians are going, technicians with the proper PPEs. Now, one important subject which very, very important subject which we have to understand is most of the time solar PV is installed based on the guidelines produced by sometimes the utilities, sometimes some agencies, sometimes the state agencies are there, sometimes central government agencies. Those guidelines are also often followed along with the standard. The state utilities are some of the state utilities. The guidelines are often asking for some requirement which is not at all included in the standard, or some, let me say, wrong methods are being propagated or are being requested for in the state utility or sometime in the central utility specifications. So the idea of this program is also to inform you that please follow the standards. Solar PV, more than shock protection, fire is a big issue. A lot of places fire accidents are happening, so we have to be very careful. People may think that, okay, rooftop, some fire, nothing happens to the building. It is not like that. Sometimes the inverter which is inside a building also can catch fire. So utilities and agencies involved make their own technical requirement. Often the requirements ask for kind of earthing. I'm not trying to cover the other subjects. I'm trying to focus on earth fault protection or protection against fire during earth fault. So in lot of cases, two earth pits are used for DC side, two earth pits for AC side, or inverter is requested, separate lightning protection is requested, sometimes chemical earths are requested. Normally, these requirements from some of the agents, I'm not saying all the agents, some of the agents actually are messing up the technical requirements. Because of this mess up, lot of safety hazards are happening within the country. So please note that these requirements are not at all included. Another issue which we see, especially in all solar systems, are lightning protection. Early streamer emission devices are used. The claim is one device protect up to 100 meters. Please note that this claim is never accepted in the Indian standard or in the IEC standard. So these EAC rods are just for namesake. It won't protect your installation. Just if somebody asks, where is your lightning protection? You can show them, yes, I have a rod. That is my EAC rod. For namesake, you can keep it. Otherwise, don't expect any safety from these rods. For example, people claim that EAC rods are as per the French standard. Since I spoke about the EFC standard, I should also show this. The French standard is asking a perfect equipotential bonding, not only the EAC rod, equipotential bonding. Whereas in our case in India, we use only the EAC rod and the rest of the items specified in the standards are not carried out. So please be sure that EAC we are not going to talk. The next important subject which you should always keep in mind is protective devices which is working in an AC environment may not work in a DC environment and most often are may not available. For example, OCPD, overcurrent protective devices, are not effective for quick disconnection of shock. In an AC circuit, in a normal electrical installation, the against the safety, against the electric shock or fault protection, the concept of protective equipotential bonding and automatic disconnection of supply is the primary safety measure. Whereas this method will not work out in solar PV, because for enabling automatic disconnection, you need to have some protective device which is able to operate within certain time. And that kind of operation, a device which is able to operate within that time, let's say, for example, 0.1 second or 0.2 second, may not be possible. OCPDs are not effective for quick disconnection. Shock protection due to lower current during disconnection. So shock protection by disconnection by OCPD is not possible. RCD for DC duty is yet to be available in the market. RCD for DC duty. DC duty means for pure DC application. Of course, RCDs type B or type B plus RCDs are available. Please note that these are AC duty RCD. AC duty in the sense the application is AC, but with a DC leakage. These are not for DC, pure DC duty. DC duty RCD is little bit different than AC duty RCD, because in DC, for example, the making and breaking shall happen in DC current. Breaking and DC current is different than making breaking an AC current. So DC duty RCD is until now is at least I don't know. I'm trying to find out a DC duty RCD, which is of course I could not found out from the market. The standards are already in place. 2017, there is an IEC standard published for DC duty RCD, but with a lot of additional testing. But so far, I think that kind of product is not available in the market. The third point is arc flash detection device, especially for series arc fault. Arc AFDDs are not available for DC application. So with the limitation of the protective devices, a totally different concept has been included in the standard. So the general concept which is followed for an AC application, please don't try to apply it in a solar PV, because, for example, the short circuit current is quite less. The operation time of the protective devices will be quite high. So the normal concepts will not work. With respect to earthing, I'm just showing a picture consisting of a PV generator and an inverter. Say, for example, the positive and negative lines are connected. PV SPD, the frame of the PV generator is connected to a common bus bar. Of course, there is an SPD as well. Then from the common bus bar, let me complete it. Okay, sub MET closer to the frame. In simple, if we say, the frame of the PV solar is connected to a bus bar, which is in turn connected to a sub bus bar meant for the equipotential bonding of the solar PV inverter, as shown in the picture where I am moving the cursor. Then from the sub MET, the connection shall come to the main equipotential earth bus bar of the building, where you have, let us say this is applicable for a rooftop installation. You have the kilowatt hour meter or the mains incoming. Near to the mains incoming, you have the MET. From the MET, the protective conductor shall be extended to the inverter. Further, it has to be extended to the frame of the solar PV installation. This is how it has to be made. The earthing of solar PV installation shall be made. People will ask, then what do we do with positive and negative? Shall we earth it or not? Never. You are never allowed to earth the positive or negative. Of course, that particular earthing is made inside the inverter, and that is the decision of the inverter manufacturer. If the inverter manufacturer recommend a positive or negative earthing, this is very much written in their manual. You have to read the manual and you have to decide whether the DC side to be earthed or not. Otherwise, DC, neither positive or negative, shall be earthed. It has to be a double insulated installation, which we will discuss later. So now this is a typical earthing layout of a rooftop solar PV. Now please note that the MET is connected to, here on the cursor I am moving the symbol 5018 for 5017 for example, but this is actually a functional bonding, means to the frame or chassis of your building. The MET is also connected to the lightning protection system, also to the extraneous conductive part, which we always discuss in our seminars. Now, see, for example, this particular network is applicable for a TNCS network. Most of the standards, if you look, even including the Indian standards, you will be able to see this picture, because the standards and regulations are made thinking that TNCS is followed by the utility. But in practical, TNCS is not followed by the utility company. As a result, we have to make a small change here. This is the connection diagram for TT system. In a TT system, all the green wires, all these green connections, that means the protective earth connections, protective or functional earth connections are electrically separated from the source earthing. See, on the left side, this is the source earthing. The consumer premise, the earthing is completely separated. First is the user or the company who is giving the solar PV connection or the contractor, they have to understand the type of electricity supply from the electricity company, and they have to select the appropriate earthing method. In the difference between TT and TNR, for example, in a TNCS network, the incoming PEN is connected to the earth bus bar of the installation. So there is a metallic fault return path to the source, to the neutral of the transformer. Whereas in TT, there is no metallic fault return path. As a result, please look at very carefully these protective device where I am making the cursor. OCPD plus RCD, type B RCD 30 milliampere. In the previous case, in case of a TNCS system, of course, OCPD is enough for the safety, basic safety. Whereas if you go for a TT system, the difference is three-phase and neutral comes from the electricity supply company. In the consumer premise, earthing is created, which is, let us say, electrically separated from the source earthing. Now, most important point is, in order to disconnect the supply during a fault condition, you are supposed to use a 30 milliampere RCD, and since your system is also connected to the DC side, DC leakages are also often dangerous, and the standard says you should use a type B RCD. Actually, type B is recommended if there is no simple separation. This we will discuss later. But as a safety measure, type B is necessary. But unfortunately, sometimes type B RCDs are not available in the market. The equipment manufacturers, such as the PCE, power conversion equipment manufacturer, he is making his own earthing arrangement inside his cabinet, including protective earthing, protective bonding, and so on. Say, for example, in this particular picture, you have they have an earth terminal or an earth bus bar. Number 3 is the incoming PE conductor. This incoming PE conductor is coming from the main distribution board or the main earth bus bar of your installation. Then internally, you see here the earthings are made. So the manufacturer already taken care of his earthing, provided the earth bus bar of the earth terminal of the power conversion equipment must be connected to the incoming earth bus bar. This incoming earth bus bar or earth wire is the wire which is coming along with the earth wire, which is coming along with the phase and the neutral of the incoming power supply. So basically, inverter as such earth pit is not required. You are supposed to connect to the incoming earth wire. Protection against electric shock. As you know, every electrical installation, protection against electric shock, there are 4 protective measures required. First is protection against electric shock. Second is protection against the thermal effect. Third is protection against overcurrent and overload or overcurrent protection. The fourth one is over voltage protection. With respect to electric shock, very important to understand that the protective measure, fault protection by protective equipotential bonding and automatic disconnection of supply is not practical. The recommended method is double or reinforced insulation. This means equipment such as PV modules, junction boxes or cabinets, cables used on the DC side up to the DC terminal of the PV inverter shall be class 2 or equivalent insulation. I'm sure all of you knows about the class 2 or reinforced or double insulation, because we are discussing about reinforced or double insulation in several of our webinars, so you know very well. On the DC side, in order to have fault protection or shock protection or protection against shock, double insulated electrical installation is recommended in the standard. The second recommendation is extra low voltage provided by SELV or PELV, where you know by limiting the voltage lesser than 125 20 volt DC. That means up to 120 volt DC, you can go for SELV, PELV requirement, extra low voltage, because there is no shock hazard. Also, basic protection is not required if the nominal voltage is lesser than 35 volt. But of course, most of the time, the DC side operating voltage is much higher than 120 volt. So the effective shock protective measure is double or reinforced insulation, double insulation. For example, the PV junction box is plastic. The wire is having an insulation, and once when you connect it to a terminal, of course, the enclosure is also plastic, double insulated material. This also means using metallic enclosures for the PV side. Let us say, for example, a combiner box. The metallic enclosures will often uh, it's a violation of the requirement of class 2 electrical insulation. Double insulation will be compromised if you use, say, for example, a metallic electrical or panel, a combiner panel. So the recommendation in the standard is equipment such as PV module, junction boxes, cabinets, cables used in the DC side up to DC terminal of the PV side shall be class 2 or equivalent insulation. Now, please note that this class 2 means double insulation. Double insulated wires are recommended as a safety measure against parallel arcing as well. So this double insulation also gives safety against parallel arcing. I'm sure in a lot of places, especially in rooftop solar installation, due to cost pressure, the double insulated installation are not very much followed. So my recommendation is please note that this is the only shock protective measure available. So you cannot or you must not violate the double insulation requirements on the DC side of the solar PV if the voltage is more than 120 volt DC. Example, how to make a double insulated wire, or if you use a normal wire, how can you achieve double insulation? These are also explained in the standard. As the first step, you please read that class 5 conductor. I'm sure we are always discussing about class 5 and class 2 conductor. Class 2 conductor means a copper wire which is having a lesser resistance. Class 5 conductor is a copper wire with a higher resistance. So class 5 conductor is allowed only in places which is subject to movement. In all the fixed part of the installation, class 2 conductor shall be used. So class 2 conductor has got a little bit lesser resistance, about 8% lesser resistance. Then of course the cost is also higher because class 2 conductor lesser resistance means more copper means more cost. The wires must have a double insulation. Say for example here, the inner core, the inner conductor, first it has got an insulation, then there is an non-metallic sheath. So this is a method to achieve double insulation. The idea is even if one insulation is broken, there is one more insulation to protect against electric shock. So these are double insulated wires, two type of wires which can be or which is recommended in the standard. You can see in the picture. If you use the normal copper wire with the normal wire which is available, you should use it inside a PVC or plastic conduit. Insulated conduits are required. So in this situation where I am moving the cursor, the wire is having an insulation which is installed inside a PVC conduit. So you have two insulation, double insulation requirement is achieved. If you are putting it in a conduit, of course you should put it inside a insulated trunking. This also means on the DC side, if you use a metallic cable trunking, normal wire cannot be put on metallic cable trunking. It should be insulated trunking. If you are using metallic trunking, the wires must be double insulated. You see here a metallic conduit, and inside the metallic conduit, the wires are double insulated. So all these wires are double insulated, another metallic trunking with a double insulated wire. So this means a normal wire inside metallic trunking is a violation of the rule for class 2 installation or violation. So you cannot do it. So different kind of achieving double insulation methods are explained in the standard. I request you please go through the standard, understand it, and try to implement. So these measures, double insulation, so far what I was explaining, these are the measures which has to be implemented in order to avoid a shock hazard, shock for human being. More than shock hazard, another dangerous problem in the solar PV is thermal effect, fire. Thermal effects are classified into the protective measures are classified into the protection against effect of insulation fault, overcurrent protection, appropriate rating of components, and signage to alert emergency service workers. These are the recommended protective measures against thermal effect. Number one, protection against the effect of insulation fault. That means in case of any insulation fault, you do something so that the solar PV is not catching fire. Number two, overcurrent protection. Of course, you must understand that the overcurrent protective devices are not very efficient, but special fuses are available, which is even able to disconnect at a current which is little bit higher than its nominal current. But please understand that it takes a lot of time. That means the electrical installation, the wiring, and the accessories must be able to withstand that particular time. Very important. Appropriate rating of the components are very much mandatory, because if you derate, this also lead to fire. But derating, please understand that in an exposed area, not only the sizing of the conductor, several other influencing factors such as sunlight, ultraviolet, chemical, mechanical, all those points must be taken care. The last protective measure is you alert somebody so that you can manually do something to stop further of a fire. Please remember that loose connections in DC is really dangerous. Now we go to the complicated part of the presentation. Especially today we are going to discuss only about protection against the effect of insulation fault. How to eliminate an insulation fault in a solar PV, especially on the DC side. First, you should understand the type of insulation failure and the type of arc in PV system. In the picture, you can see there are three types of arc. The first one is the series, means there is a loose contact in a terminal, and there is a series arc. Say, for example, these two series arc. Arc to earth means there is an insulation failure and the wire is touching some metallic part. That means the double insulation itself has broken, and insulating the wire is in the conductive part is in touch with exposed or extraneous conductive part. As a result, the series arc is happening. Arc to earth is happening. There are two chances. One is arc from the wiring. Next one is arc within the PV module. Then parallel arc. Parallel arc is the arc between two DC wires, like the positive and negative wires. But please note that against parallel arc, the double insulation is providing certain amount of protection, because double insulation means even if one insulation goes off, there is one more insulation to protect the people. I will just show you what is written in the standard about this particular subject. Very interesting to read. I'm just showing you the standard 60. This is an Indian standard. Let me show you. IS 16997 or 6036477712. I go to the annexure just to show you about the dangers of arc, which is, as I said, most important, because fire in solar is a big headache at the moment in the country. Annexure informative. Arc fault detection and interruption of PV arrays. Unlike traditional electrical products, the PV modules and wiring do not have an overall enclosure to contain arc and fires resulting from components of wiring fault. Many PV installations operate at DC voltage, which are very capable of sustaining DC arc. There are three main categories of arcs in PV installation. series arc which may result from a faulty connection or a series break in the wiring, a parallel arc which may result as a partial short circuit between adjacent wiring which is at different potentials, arc to earth which result from failure of insulation. Now further if we go, if an arc develops due to fault in PV array, this can result in significant damage to the array and may also result in damage to adjacent wiring and building structure. The most serious arc is likely to be parallel arc because of the energy that is available to feed this type of arc, especially when the arc is between the main PV array conductors. So as I said, against parallel arc, of course, double insulation is the most important safety measure, but most of the time inside the combiner boxes, the double insulation requirements are compromised. This is one of the reasons. Combiner boxes, if you look in the Google, you can find out several videos where the combiner boxes are burning. It never stops and it keep on burning because the PV module is pumping energy into the combiner box. Double insulation is compromised. As a result, it catches fire. So this document requires cable in PV array. You read here, I am just highlighting. This document requires cable in PV array wiring to be suitable to be used with class 2 equipment, and because of this requirement, parallel arcs are very unlikely. If we read it in another way, if you use class 2 wiring or class 2 equipment, the parallel arc likely. That means if you compromise it, they are likely. Unless caused as a result of significant insulation damage due to fire damage and severe mechanical damage to cables. The most likely type of arc to occur in a PV installation is a series arc. This is because PV installation typically contain a very large number of series connections. So now I hope you understood the seriousness of the subject. I am just showing the standard just to inform you that the situation in DC is not like an AC side. We have to apply separate or special protective measures. Now, for example, series arc, in a AC system, we have the arc flash detection device, AFDD, which is recommended, for example, in bedrooms, wiring in explosive areas, and so on. Whereas that kind of a device is not available for DC application. So, for example, here what the standard says, a new standard has been developed by Underwriters Laboratory UL1699B photovoltaic DC arc fault protection device. But unfortunately, there is no product available in the market until now. Now, with this background, let me go back to my presentation. For the purpose of finding out the fault and disconnecting the fault, several methods are incorporated, several methods are implemented or recommended in the standard. This part of the standard actually it's highly confusing. Basically, there are three types of categories: a non-separated PV array system. Non-separated means the DC side and the AC side are not electrically separated. So electrical separation is possible either by a transformer or nowadays electrical separation is possible by the semiconductor devices. So basically, non-separated PV array means the DC side and the AC side does not have any electrical separation. Functionally earthed PV array. Third one is non-earthed PV array system. These three categories are made, and the fault protective measure against fire thermal effect has to be implemented based on the recommended measure for a typical application. One of the example, functionally earthed PV system. Functionally earthed PV system in the sense, I start from the left side. You have the AC mains. You have the AC mains may be earthed or unearthed. External transformer, you have the PCE, that means just before the PCE, power conversion, or just before the inverter, you have a transformer which is electrically isolating the AC mains and the PV installation, including the inverter. Now the PV module, including the inverter, which is at the secondary side of the external transformer, is functionally earthed. You see here, this one, functionally earthed. Functionally earthed means this earthing has got certain purpose. Number one, this earthing will create a stable voltage on that particular line from the secondary side of the transformer up to the last PV module. The voltage is stable. And very important, the functional earthing is always made with a kind of a device. For example, at this circuit, PV array functional earthing, there can be a fuse, there can be a protective device, there can be a relay, there can be some kind of switching device, or there can be an impedance. The idea is, in case of, let me draw it one moment. Yeah. Okay. In case, imagine, in case of a fault here on the DC side, the fault current is returning back to the source through this functional earthing terminal. Let us say this functional earthing, imagine there is a 1 amp fuse. So there is a functional earthing and there is a protective device in that particular circuit. Once when the current is more than certain limit, this current can be disconnected. This device will disconnect the functional earthing. Number one, all of you, the user and the PCE and the electronics, know that the functional earthing has been disconnected because there is a fault somewhere in the DC side. Since the functional earthing is disconnected, there is no fault current flow. As a result, your system is still in. So as I said, the methods implemented in DC is little bit different than in, or the method implemented in a solar PV is little bit different than what we generally do for AC applications. So we have to be very careful. This one is a functionally earthed PV system with the internal separation. That means the PCE is having a transformer inside. The electrical isolation internal happening within the power conversion equipment. Here also you can see the functionally earthed system. This one is a non-separated DC system, but again functionally earthed. Functionally earthed, as I said, the purpose of the functional earthing is whenever there is a fault in this particular circuit, the fault current will return back through this functionally earthed wire. And on that wire, there is a measurement mechanism and there is a disconnection mechanism provided with the help of maybe a fuse or with the help of an OCPD or relay or contactor or whatever it is. There is a mechanism available in this route. As a result, whenever the current is more than certain limit, the functional earthing is disconnected. Once when the functional earthing is disconnected, say for example, this functional earthing is disconnected. Under that condition, your entire system is floating. The single fault, you know, in a floating system, single fault do not create a hazard. So that is the technique which is applied in a functionally earthed system. The second type of system is non-earth referenced PV system. Non-earth referenced PV system means it's completely floating. You need to have a insulation monitoring device, and there are certain insulation levels applied. If the insulation level is lesser than the limit, recommended limit, it's very easy. You can find out and you can take the necessary step. So the second one, non-earth referenced PV system. Again, non-earth referenced PV system, say for example, here you have a PCE with an external transformer. The same circuit PCE with an internal transformer is possible. The non-separated system with the inverter, where non-separated, you see the inverter doesn't have any electrical separation between AC and DC. Say for example, in this particular case, please try to understand the circuit. So there is an AC mains. The AC mains, the neutral is earthed. Now the PCE doesn't have any electrical separation. That means electrically the PV module and the AC side is connected. Imagine there is an earth fault in the PV side. The fault current will return back to the system through the neutral earthing. The safety measure recommended is, if there is a current measurement, or if you find that, say for example, on the PV side, the insulation resistance is lesser than certain limit, what you should do is you should disconnect the AC supply in order to have safety from an earth fault or from a fault at the DC side of the PV array. We have to disconnect the AC side in this particular case, because by disconnecting the AC supply, the return path is disconnected. As a result, the chance of fire has been minimized. This system also with the DC-DC converter, the same method. So you have a non-separated DC-DC inverter, and in case of fault, you are supposed to disconnect the incoming supply. So basically what I wanted to tell you is there are different combinations available. And these combinations are mainly decided by the inverter manufacturer. The inverter manufacturer will tell you what kind of system you are supposed to follow. One of the problems which I have seen is the inverter manufacturer is recommending, let's say, for example, X topology. But without understanding the topology, a Y topology is made in the installation. This is a hazard. We are not supposed to do it. We should really understand what the inverter manufacturer thought for this particular safety measure, and we have to implement the correct safety measure. Now, to implement this correct measure, the designer of the solar PV system, he has to carefully analyze and he has to understand the different topologies which is applied along with the necessary protective measure. Say, for example, this is an unearthed system. PVDC configuration, arrangement of an unearthed system. Unearthed, what is unearthed? This side, the DC side is unearthed. The DC side is unearthed. The positive and negative is completely double insulated. It is connected to the PCE without a transformer inside, and the PCE is connected to the incoming power supply, the phase and the neutral power supply. Now, under this condition, technically, the DC side is electrically connected to the incoming because of the neutral earthing of the incoming transformer, of the supply transformer. It can be a supply transformer from the utility company. Unearthed PV array connected to the AC side via a PC without a transformer, non-isolated inverter. Earthed line of AC main is the reference of at the DC side. Earthed line of AC main is the reference at the DC side. The first safety measure what you should understand is never try to earth this neutral. Never connect this neutral to earth, which is often I have seen in several places, the neutral which is coming from or the neutral terminal of the inverter is connected to earth, which is a big violation of the safety measure. Please don't do it. The neutral under this condition is completely isolated. One moment, let me erase. Yeah. So here, what you are seeing in the picture is a PVDC. You have the inverter which doesn't have electrical isolation. So the PV side is referenced to the neutral of the incoming supply or to one of the phase of the incoming supply if it is a three-phase. In single-phase inverters, in a lot of places, neutral of the inverter is connected to earth. I have even seen one of the utilities recommendation. They say that neutral of the inverter shall be connected to 2 earth pits, which is wrong. Please don't do it. Here, the safety measure is in case of any fault at the DC side, the incoming supply will be isolated, and this feature must be inbuilt in the PCE. If the PCE particular feature, of course your solar PV will be in trouble. It can catch fire. Now, in a non-isolated inverter, an array grounded fault will result in potentially hazard current flow during operation due to the earth neutral of the mains, so inverter must not connect to the mains. Another condition, PVDC, arrangement of earthing system. Now, in this particular case, this is a PCE with transformer inside. That means the inverter with an isolation transformer inside. That means the AC side and DC side are electrically isolated. Under this condition, you see here the negative in the picture. The negative is functionally earthed. I am sure you are aware of this functional earthing. Symbol 5018. Functional earthing is made for certain application. It is not for safety. It is not a fault return path. It has to do something for the functioning of the whole system. That is how it is. In an isolated inverter, if the first ground fault in a floating or functional ground array goes undetected, a second fault can cause a hazardous current to flow. The first fault, as a result, first fault may not be dangerous, but second fault may be very much dangerous. So the safety measure which has to be implemented is the first fault itself must be detected and avoided. So the detection and indication of the first fault is required, but the inverter is allowed to connect and commence operation because of the isolation of the inverter means the earth neutral of the mains will not provide a return current for the earth fault. So to simply understand, I will explain it in a normal language. Imagine you have a three-phase inverter with a transformer, and this particular connection where I am highlighting, that means the functional earthing, is already made inside the PCE. The inverter manufacturer has taken care of it. He has already made the connection inside. It means the entire DC side electrical installation must be double insulated. You are not supposed to earth neither positive or negative because that is already taken care by the inverter manufacturer. If the inverter manufacturer is not taking care of it, he must be writing it in his manual. And then if he has written it in his manual, then it is the job of the installer to take appropriate measure. Now, whether the PCE manufacturer make this facility inside the inverter is a big question because nowadays for solar PV, we go day by day, we try to reduce the cost. You have to be sure that if you try to reduce the cost of the inverter or the PCE, then of course such safety measures also will be extra. They will simply remove it and they will put it in the manual. So the installer have to read it, understand it, and they have to put it in the system. Now, how the system works? It's very simple. All of you know that unearthed system, IT system, the first fault is not going to create a safety hazard. Now imagine in this particular case, let me see the rating of the fuse which has to be implemented here. Say for example, this one. Rated current of automatic disconnection device in the functional earthing conductor. That means the wire, the functional earthing wire is having a fuse. Here you have the fuse, and the fuse rating is based on the PV array kilowatt hour, kWp. For example, 0 to 25 kilowatt, the fuse is 1 amps. 100 to 250 kilowatt, it is 4 amps. More than 250 kilowatt, 5 amps. 25 to 50, it is 2 amps. Basically, this kind of a fuse is implemented in this location. Now, whenever there is a fault on the PV array, between the PV array or between the lines to exposed or extraneous conductive part, we have to ensure that the earthing arrangement is made in such a way that the fault current is returning back to the source through this path. This path means through that particular fuse. Let's say 1 ampere fuse, up to 1 ampere. This means up to 25 kilowatt solar PV, a fault current of 1 amps is less than 1 amp is not hazardous, more than 1 amp is hazardous. 1 amp fuse, you must understand that the fuse has got a certain disconnecting principle or disconnecting method. Say, for example, 1.45 times the rated current will take up to 1 hour. That means 1.45 amps over current will take the fuse or the MCB will take almost 1 hour to disconnect. So all these calculations are already made. Simply the installer must ensure that in case of any fault in the DC side of the system, the fault current must return back to the system through this particular functional earthing. And if the current is more than the required or the current, then the fuse disconnects. Now, once when the fuse disconnects, let me draw it again. Once when the fuse disconnects, let us say this is not existing. Once when the fuse disconnects the functional earthing, then what happens is the DC side is completely in a floating way. It is like an IT system, unearthed system. Unearthed system with a single fault. Say, for example, there is a fault, unearthed system with a single fault, which is not hazardous. There is no fault current. As a result, you have detected that there is a fault and you know that the system is still safe. So before the fault, the second fault comes, you should take care of the installation. That is how it is. So now, if you use a combination, one transformer with so many inverters, sometimes people use, they buy inverters without transformer, and sometimes 5 inverters are connected to one isolation transformer. You should also look into these requirements. There shall be no other equipment connected to the same winding of the external transformer as the PCE. That means you have a dedicated transformer for each PCE, and you shall not connect the secondary winding of the transformer to a load other than PCE. And if you use it where the system is rated only for use in closed electrical operating areas, other equipment is allowed to be connected to the same winding of the PCE output as other PCEs, if specially rated for connecting to a common winding. Now, where this is applicable, let me take the picture. Say, for example, this picture, you have a isolation transformer for your solar PV. Now the standard recommends this isolation transformer must be exclusive to this particular PCE. You have to use it exclusive. If you wanted to use the same isolation transformer for multiple PCEs, then that PCE should have some extra safety measures. So you have to check with the PCE manufacturer's catalog and find out whether it is allowed to connect a PCE without internal separation is allowed to connect to common transformer. You have to be careful in that particular case. I'm sure most of you are already doing it. This is how the earth fault protection is achieved. Please note that earth fault protection, what we are talking is not against protection from electric shock, but it is against protection from fire. Protection from electric shock is achieved only by double insulation of the DC side. Now, protection against thermal effect. See, different kind of systems. You can find this kind of a table in the respective standard in almost all the solar PV standards. You can see these configurations: non-separated, functionally earthed, non-reference earthed, and you can see here. Plus, the necessary safety measures are also included in the standard. Say, for example, PV array to earth insulation resistance monitoring. So, 2 safety measures which is included is, one is insulation resistance monitoring. That means the PV array, depending upon its capacity, should have certain minimum insulation resistance. So say, for example, up to 20 kilowatt, 30 kilo ohm insulation resistance, and more than 500 kilowatt, 1 meg ohm, 1 kilo ohm insulation resistance is required. So the insulation resistance of the system is measured, and by measuring the insulation resistance, if the insulation indication of the earth fault, see here what safety measure, stop and disconnect all poles of PV array from earthed load side of the system. So on the earthed side of the load, earthed side, either you can disconnect the earthing, or you can disconnect the load, or you can disconnect a part of the PV which has created the fault, provided you have a monitoring system for each and every circuit. So that part of the circuit, either you can disconnect, or you can disconnect the functional earthing. As a result, safety is achieved. This is one method, insulation resistance monitoring. The next method is residual current monitoring. Residual current monitoring is the current which is flowing through the functional earthing system is monitored, and the functional earthing is disconnected in order to achieve safety. So these are some of the techniques which is used for fire protection in solar PV. If you use the functional earthing, you should also note down, for example, for functional reasons, some PV module technologies require a live part to be connected to earth. So not only the PV module, not only the inverter, the compatibility of inverter and the PV module must be made in common. Second, functional earthing of live part of DC side of a PV permitted if there is at least a simple separation AC side and the DC side by means of a transformer having electrical separation. So functional earthing is possible only if you have an electrical separation, whether internal or outside. If you doesn't have electrical separation, I'm sure most of the time nowadays the market is using PCE without electrical separation, because without electrical separation is cheaper. So we have to adopt some additional safety measures. So all these conditions has to be fulfilled in order to have a safe system. As I said, through the functional earthing, depending upon the capacity of the installed PV array or PV, the capacity, you are supposed to measure the current and you are supposed to disconnect. Similarly, impulse voltage, safety against over voltage, each part of the electrical installation of the PV must withstand certain impulse voltage withstand. Of course, in the PV module, these impulse voltages are ensured by the PV module manufacturer, depending upon its voltage. But at some point, the PCE, you have to be very careful. If you are buying a PCE which is not tested as per the standard, you have to be careful, and you have to ensure that the PCE is rated for this or tested for this particular parameter. What I have seen is most of the inverters which is sold or used in India, or sometimes this parameter is not tested. The danger is it can fail anytime and it can catch fire. So you have to use an inverter which is electrically or which is tested for all these parameters. Now, earthing, one of the picture, you can see here the shielded wire is coming. The shielding is connected to the combiner box. The combiner box here you see there is a small bus bar made, and the protective conductor is connected to the inverter, and the protective conductor goes towards the AC incoming. This is nothing but in case of a TNCS system, it goes to the neutral of the transformer. In case of a TT, it goes to the earth electrode. So this is how earthing has to be made. Of course, as I said, the separate earthing of DC, separate earthing of neutral of the inverter, all these are illegal. Please don't do it. One of the subject which you should always keep in mind is an inrush current, probably a lightning current, or any current which is having a larger di by dt, that means the rate of change of current is high, may induce voltages into the module, into the array, and this may damage the insulation of your PV modules or PV array. We have to be very careful. Probably the lightning is 1 kilometer away, but that lightning can induce voltage into your system if the system wiring is not carried out properly. For example, here there are two types of wirings shown. You see here, in the first case, from the combiner box, the positive is coming, it is looped to each and every module, then it is coming back like this. In the second case, so it is looped, and you see here the wiring is made in such a way that the loop is reduced to a very less extent. So in this condition, if there is a lightning strike, voltage is created in the combiner box, and in the first case, due to the large loop, a high voltage is created in the combiner box, which may result in the failure of the PV system. Whereas in the second case, the loop is reduced to a very low level. As a result, the induced voltage is very much less. So basically, the wiring which you are doing on the DC side, you should ensure that the positive and negative wires are routed in such a way that the loop is reduced to a very low level. And here you can see this recommendation in the standard. Each module, you see, the positive and negative should run parallelly. The return conductor also should run very close, in close proximity. Both these wires should run in close proximity. Very important. Otherwise, it may lead to failure. So now, coming to lightning protection, of course, the recommended method is in the standard. You have to have a mesh, you have to have individual rods, and you can apply the technique such as the rolling sphere in the air termination, so that lightning is not striking the building or the PV directly. Two techniques which is applied is the one is electrical separation. Electrical separation means the lightning protection system is away from the solar PV module. It is away. That means the solar PV, there is no arc over or flash over from the lightning protection system due to a lightning or at the time of lightning to the PV, because the distance, the separation distance is calculated and maintained here, the separation distance. The rod is away from the PV module. The conductor is away from the PV module. This is one technique. Let me skip this particular part. Lightning protection and surge protection shall be, you should not make lightning protection a separate idea and surge protection a separate idea. No, both has to be combined in such a way that depending upon the type of lightning protection, let me show it, you should select the wiring. The size of the wiring has to be made in size of the wiring, and the type of SPD shall be selected based on whether you have an external lightning protection system or not. For example, if there is no external lightning protection system, the equipotential bonding wire shall be 6 square millimeters, and the location 1, 2, and 3, 4. 1, 2, and 3, 4 is, see here, this is location 1. Location 1 means AC side, location 2 means between the kilowatt hour meter and the inverter, location 3 means at the DC side. So if you have no external lightning protection, all the locations you can go for type 2 SPD. If you go for with external lightning protection, separation distance is maintained, then type 1 SPD is required at the mains incoming, type 2 for the other locations. And if the lightning protection is with the building is with external lightning protection, separation distance is not maintained, which is generally in all the cases we do this one. No separation distance is maintained. The lightning protection air termination and the frame of the solar PV are often connected, or it is running very close by without calculating the separation distance. Under that condition, the minimum equipotential bonding conductor must be 16 square millimeters, and you should use the type 1 SPD in all the locations. It is not a type 2 SPD, it is type 1 SPD. So you have to be careful in this particular case. Now, my presentation is so long. Now let me find out some additional information which I can give. One information which I wanted to provide is, one moment, by mistake I unshared the one information which I wanted to share to you is the earthing of a large PV installation. You can see here. ground mounted system. So here you have the control room, you have the main earthing bus bar, you have finally the earthing is made as a grid interconnecting every frame of the solar PV. The grid size can be based on the recommendation from the standard. For example, this one is from the standard IEC TR 62738. The standard says at least at every 20 meter you are supposed to have an interconnection. That means you are supposed to make a grid of, let's say, for example, 40 meter, and at least at 20 meter you are supposed to have a connection. But this connection, the size of the grid shall be made based on the soil resistivity. You have to analyze the soil resistivity, and there are certain calculations, and then you have to find out the size of the grid, and the frequency of interconnection must be made. So basically, the whole solar PV, we are not talking about the earth electrode, vertical earth electrodes. So by this, I would like to stop the presentation of today. You can find out, sorry, there is a small mistake in my mobile number. Say, for example, my number is 99625222244. So in somewhere I copied a wrong number, and a lot of people are calling on the wrong number. So by this, I would like to stop the presentation. Thank you very much. Maybe we can have a small question and answer. Over to you, Mr. Dominic.
Yeah, thank you. Lakshmi, just type the phone number. I think the phone number is also, I think email it is better, because you'll be traveling a lot and there'll be calls coming up. Good one. So wonderful participations. As I said, we had 890 registrations. Out of that, we have almost 300 participations. So Sunday being a learning day, a good response. I want to thank all the participants very patiently. Normally, the question answers is very interesting, interactive. So I would request all the participants to stay back. We will have 20-25 minutes of question answer, and we quickly will run. So I'll just take up the questions from Pramod Dwivedi, please. Okay, that's about the PPT. Yes, of course, the recording of this webinar will be available in the blog of Mr. Gopakumar, and also we'll be sharing individual to everyone. Mahesh is asking, is it chemical earthing is accepted as per the pollution control or statutory requirement?
Actually, this is a common question in almost all our seminars. There is nothing called the chemical earthing. It's an illusion. People think that by putting some chemical into soil, all the problems go to soil. There is nothing called the chemical, or you cannot improve your system by adding some chemical into the soil. Even if you achieve a 0.1 ohm, your system is not going to improve. System improvement has to be made with some other ideas, which we are always discussing. Please don't think that earthing and earth electrode are not the same. Chemical earth is just an earth electrode in soil. Earthing is a subject which is talking about the interconnection of different exposed and extraneous conductive parts of your installation, and finally monitoring the current and disconnecting the current without creating a shock or fire.
So Venkateshan is asking, I think the last two slides that shows it would have answered your question. Anyway, in this case, how many earth pits should we have, or how to determine the number of earth pits?
If you have a solar PV, rooftop solar PV installation, for the solar PV installation, you need a 0 earth pit. You have to connect it to the incoming earth bus bar, the earth wire coming along with the phase and the neutral. You should do it. 0 earth pits are required for rooftop. If it is a, your question is generic. Now I cannot make a general answer. Now, if your application is for a large PV installation, land-based installation, then of course you need an earth grid interconnecting all the frames.
Swaz is asking, what is the difference between the PV SPD 3 and 4?
Yes, if the DC, the distance of the DC wiring is so long, then if it is more than 10-15 meters or sometimes 25 meters, and if it is put through plastic conduits, then you require one more SPD or additional SPDs on the DC side, sometime near to a combiner box, sometime near to a module. It all depends on the type of wiring which you are adopting.
Okay, Syed, Mr. Gopakumar will write to you separately on this question that you asked. I'm sure he will quickly do this today. Okay, I am not going to take any anonymous questions. It will only if you mention your name, I will take it up. Nathan Varadarajan, sorry. On my consultancy advice, to PSN Solar Energy kitchen appliances, Kadalur, just started 2 months ago. We initially go in for direct DC appliances for supplying boiled milk to rural through roadside tea shops. Please advise us whether we can go for directly connected SPV panel, taking care that the connections are shockproof by conventional earthing.
Actually, this question need an evaluation. By simply making the answer, it may be confusing all the participants. The first one for shock, I understood that your application is some kind of a small heating application for roadside tea shops. But tea shop in that particular case, if the voltage is quite less, let's say 24 or 38 or some low voltage, in that case, the insulation and the situation is different. The shock is different. You can even go for an unearthed system. So it purely, the question need to be understood very carefully, and then only I can answer that. So I don't want to make a direct answer.
Okay, Sir Giridhar is asking what is the difference between IS and I think IEC, IES difference. I don't know what is. Okay, you understand.
Mr. Dominic, one of the anonymous person, he has asked the question: if the lightning protection is connected to MET during lightning, high voltage will destroy the solar PV. That is what they asked. Actually, it is not correct. During lightning, we have to create an equipotential bonding system in such a way that there is no potential difference. If there is a potential difference, then only failure comes. So equipotential bonding must be very much accurate. Then the question regarding IS and IEC, of course, IS stands for Indian standards, IEC stands for International Electrotechnical Commission standards. IS standards are actually following IEC. So if there is an IS not available, we can refer IEC standards. So both are almost the same. Not almost, it is the same.
Sir Pradeep is asking, please explain, conversion equipment should be near to PV module or injection point?
It depends on the size of the system. Say, for example, if you are having a small rooftop system, then of course it can be closer. The inverter can be closer to the PV module. It all depends on the convenience of our, the place where we are going to install. So there is nothing like a thumb rule. There is nothing like a thumb rule saying that for this application it should be closer, this application it should be far away. The only point is that if the DC is far away, then we should think that the double insulation rules shall not be violated.
Tamil Vanan is asking, sir, if both insulation get fail in double insulation method, what do you do?
People will die if the voltage is more than 120 volt, or if the installation can catch fire. Both can happen.
Again, anonymous, hope the same person is asking this question. How many solar panel and battery for three-phase line was the high kVA for solar panel?
Oh, actually, the question is not clear. We have to skip. Okay,
sir. So, Varghese, what will be the method of firefighting if the PV solar module get the fire in a sunny day? Inverter gets switched off and the grid go off. Firefighting method, you need to have an extinguishers, chemical extinguishing on the near the battery room. Is it asking for a battery inverter?
Actually, this has to be, we have to think it in two ways. One is the fire created in the PV system because of a fault. That can be handled by protective measures such as disconnection isolation. Number two, if it has already, the fire is not extinguishable, in that case, we have to go for firefighting system, such as whatever the firefighting methods. So two subjects are actually distinct. One is avoiding the ignition of fire. Second one is after the fire, how can we make the system safe?
Same related question. Mallikarjun is asking, the use of insulated conduit for DC cables protection may increase the fire load on the rooftop. How do we overcome this?
That is also true, because if we use more and more plastic, more and more chance of smoke, which is again dangerous. Parallelly, you see, not only the double insulation, the other with respect to fire, series arc, parallel arc, and the earth fault. Now, if we look at very carefully, the PVC conduit or the traditional or the double insulation is for shock protection. With respect to fire protection, it is not the PVC conduit; it is the disconnection. So both the protective measures are distinct; they are not the same. We need both the protective measure. That is the point.
Okay, Snehash is asking, should AC and DC earthing should be bonded in solar plants or kept separate?
Actually, this is the common question which a lot of people ask. AC earthing and DC earthing shall be connected together or not? Please understand that there is nothing called DC earthing. DC means the positive and negative of the solar PV. Positive and negative, you are not supposed to earth any of these conductors unless and until the inverter manufacturer allows. Normally, the safety measure shall be made inside the inverter by the manufacturer. So forget about the DC side. Now on the DC side, what you have is the frame of the module. Frame of the module is not actually DC. We should call it as exposed conductive part. In a building, all exposed and extraneous conductive parts must be interconnected. So it is a problem of the question. Don't think that please forget about the DC side. It is not DC earthing. It is the frame of the module where the module is fixed. It is not DC. It is exposed conductive part. Exposed conductive part must be connected to the equipotential bonding system. DC side, of course, you should look at the inverter manufacturer's recommendation.
I think Rishabh, I think that answer that he gave related to your question also. So I'm going to skip this question. Okay. Sir Pramod is asking, my chemical storage area is 3.5 meters, width, breadth, 4.0 meters, and height is 3.5 meters, and chemical storage of class A is 2.
No. This question is not related to solar PV. It is related to lightning protection. We will discuss it during the lightning protection class.
Okay. Debat Jyoti Mukherjee, instead of having double insulation in PV wire, still there is an insulation failure and arc developed. Need to understand the problem and how to resolve it.
Yeah. Mr. Mukherjee, so if this arc or if this fault is existing for a longer time, it catch fire. Longer time, maybe more than sometime 1 second or 2 seconds itself is dangerous. Now, you should find out the method of detecting this fault and the method of isolating this fault. There are different techniques involved. One of the technique is your AC and DC side are electrically separated or there is no electrical separation. So based on this first question, the second question comes whether it is functionally earthed or functionally not earthed. Then the third question comes, if it is functionally earthed, of course, you can disconnect the functionally earthed system. Better you switch off the system, you remove the functionally earthed system, you switch off your solar PV, you find out the fault, you rectify the fault, and then you put it into service. So these safety measures are very much documented in the respective technical books or the technical standards. You should actually follow those technical standards.
Okay, sir. Malikarjun is asking this, sir. The ground-mounted solar PV earthing system, as per the IEC 62738, it indicates 20 into 20, 20 into 20 grid, or to be calculated as per a certain calculation. However, there is no reference provided for calculations requested to guide.
Yeah, you can, we are actually making this calculation. We are helping a lot of clients in making this calculation. I can send you a list of questions, and if you can answer the question, we can make it.
So,
Thank you.
Malikarjun, you can write to Mr. Gopakumar, he will respond to you. Ramakant Sharma, what is the safe electrical separation distance between PV and lightning protection?
Oh, it depends on on several factors: lightning protection level, the number of down conductors, type of insulation. Sometime in a multi-storied building, let's say 20-30 floors building, then probably 2-3 meters are required. Sometime in a smaller building, maybe 200 millimeter is required. It all depends on the type of the function, the parameters such as the expected lightning current, length of the down conductor, number of down conductor, type of insulation, and so on. So these calculations shall be made.
Yelling, I think the answer is already now given. I will go to Jay Gupta's questions. We have 100 megawatt floating PV power plant over large water reservoir. What protection measure in terms of earthing and fire protection we shall look into beside another 100 megawatt land solar separately as well?
Yeah, actually, this kind of a system, we cannot make a generic answer. If we make a generic answer, probably the answer is wrong. We really need to understand the system. We need to find out the kind of topologies recommended or in the inverter manufacturer's catalog and all. Then we have to decide it upon. I would recommend not to answer this question right now. If you have any question, you can send your detailed email. Probably we will ask maybe 20 questions to you, and if we are clear about the system, then I can answer properly. Thank you very much for the question.
So, Jay Gupta ji, please write to Mr. Gopakumar separately on this. So, John Varghese, his earthing and ground are same. I think
Yes.
we did webinar on, I think that's available. Please have a visit our blog of Mr. Gopakumar, you will find the answer for that. So, Vijay Malviya, GA earthing and copper earthing and aluminum earthing are earthing area. Please clarify. Again, it's on earthing. We have already done this. Please visit the our previous webinar. You'll get an answer. Okay, do courses. Someone has asked Gopakumar, can you do practical, seminar or visit their place and conduct classes for them? So we told them to write to you. There are many questions asked. How do you do practical classes for this? I think you can reply to Basil also based on the Basil Raymond. You can write to Mr. Gopakumar. His mail ID is already given here. So Puneet, what devices is best for automatic changeover when it comes to diesel generator, solar ACDB, and LT panel, which are interconnected, so it to ease the automatic changeover in safer way?
What device is best for automatic changeover? Oh, there are several methods available. So several changeover mechanisms are there. For example, starting with the mechanical, then nowadays semiconductor-based changeover systems are also available. It depends how much, what kind of, or what fast switching over you require, and how much money or how safe you wanted to make it. There are several methods available.
Okay, Lawrence Sarandraj is asking, in large size solar power like 300 kilowatt, how many earthing required for DC and AC side if SPD required for separate earthing strip?
Mr. Lawrence, we are not talking anything separate. Earthing in this particular case means your 300 kilowatt solar PV panels are mounted in a frame. these frames must be interconnected through a conductor, and this conductor has to be a buried conductor. It has to be buried in soil. That is your earth electrode. So finally, the frame, 300 kilowatt frame, which is on the DC side, the same conductor will come up to the inverter, and the inverter frame is also connected to the same grid. Along with the phase and neutral, the positive and negative, it is recommended to have one more earth conductor, but anyway, that is a different case. Then from the inverter upstream towards the transformer, we will ask the question whether the kind of network you are using, is it a TNS network, TNCS or TT network? If it is TT, you have to connect the earth bus bar near the inverter to the earth electrode through the main distribution board. So if from your question, what I understood is you are asking how many earth pits, earth electrodes, vertical pipe or chemical is required in AC and DC side. I would say 0. You have to interconnect. Earthing means you are interconnecting the exposed and extraneous conductive parts to a common system. That is earthing.
Sir, Davies is asking functional earthing disconnections and human safety. Can you explain this? Do you have time to do that?
Sir, actually, we have made a lot of webinars regarding IT system. IT system means unearthed system. In an unearthed system, even if somebody touches a live conductor, there is no shock because there is no fault return path. In a functional earthing, for the purpose of stable operation of the system, a functional earthing is made. Now, the stable operation is destroyed or disturbed because of the fault. During the fault, you disconnect the functional earthing. As a result, fault return is not existing. And then the fault becomes a single fault, unearthed system. There is no fault current and the system is stable. So first you should understand the unearthed system. Then you will be able to understand this.
Sir, unknown attendee, how can we calculate number of earth pits for DC, AC and lightning?
My God. Gentlemen, we are not talking about the earth pit calculation. Your question is still 30 years old question. Nowadays, no one talks about earth pit. Please try to change your idea of this earth pit. If I would even make the comment that people, those who are still making the earth pit calculation, they are unfit for working as an electrical engineer. Sorry to say that.
I think what we will do is 12:40. There are a few more questions that we will answer to you one to one. Why I need to stop, because I need to tell you that I would like our Gopakumar to talk about very interesting, because now we had almost 300 registration. We should have spoken about the new society in India for the first time that we are going to launch very soon, and probably next 25-30 days, for the electrical safety engineers. So I would like to Mr. Gokumar to talk about a bit on that, so that the remaining people here understand about the society that we are rolling out.
Yes, one moment. Let me open this.
Because in India, we do not have a platform or society that talks about electrical safety, or for the electrical engineers, a safety forum. So Mr. Gopkumar's novel thinking that NFE, National Federation for Engineers for Electrical Safety, NFE, is going to be launched. More from Mr. Gopakumar on this.
Yeah, actually, participants, all these last 2.5 or 3 years after the COVID, the amount of work we combinedly doing, in the sense, myself, Mr. Appavu sir, the retired Chief Electrical Inspector of Government of Tamil Nadu, Mr. James Kuti Thomas from retired Electrical Inspector from Kerala, along with other experts, we were doing a lot of activities in online classes, then answering through WhatsApp groups and making technical literature and so on. Mostly our programs, or mostly the effort which we are doing, is it's not organized. It is going unnoticed, and sometimes we felt that a lot of requests came from the electrical engineers, from the electrical inspectorate. They are requesting to make a common platform so that all the technical issues can be discussed. As a result, we were planning to register a society. Of course, the registration is already over. Official announcement will come very soon. We are registering a society, sorry, not registering, already registered. National Federation of Engineers for Electrical Safety. This is a society. The vision of the society is to make, the nation electrical safe, and the people shall not die due to electricity, and we have to make the installation safe. The vision, mission, and the functions of the associations are already fixed. One of the responsibilities which we are trying to do is, of course, training people, making the product more and more reliable. That means we have to, the engineers from the manufacturers have to be educated about the latest and the modern standards so that they can design and make, test modern equipments. So with this vision, we have registered the idea. We will come back with official announcement very soon. We request the participation from each one of you so that this association can be made, or we can make our own rules and regulations, and we can guide the whole the nation for a safe electrical installation.
Good. Thank you, sir. Let's see what NFE is going to do. And I would like everyone to be, coming forward to become a member of the society. Cedric, you raised the hand. I just, Rajkumar, I'll just give, if it is less than a minute, I'll allow you to speak. Cedric, a question.
Yeah. Good morning. Thank you very much for some very good discussion on that. Okay. Can you, Mr. Gopal? Can you accept me on LinkedIn? I'm Cedric Almonte. I'm one of the QHSE manager for the first solar power plant in Qatar, and we have another solar power plant awarded for the Samsung. I have so I can chat with you privately, so we can work together.
Oh, welcome, Cedric. I know Qatar now in festive mood for the football. I think after the football World Cup, probably you can get in touch with him. And yes, of course, he is an international figure now.
Yeah. My current previous project now is the first solar power plant in Qatar, and that will be utilized for the FIFA World Cup. Yeah, we already adjust this one.
Wonderful, wonderful, wonderful.
Yeah.
Welcome, sir. Welcome. Ladies and gentlemen, thank you so much. Sunday being a relaxed day with family, we have taken away your precious time, but I'm sure you would have enjoyed this session, and a lot of appreciation I could see in the chat. And it was a crisp and pointed presentation by Mr. Gopakumar and Cape. We love to see you again. I think next one, what we are talking about, how to do electrical audit. There are various type of audit that's happening in the country. Which one is the right? So we'll come back to you soon on the next session that's going to have, probably in the first week of December. We're going to talk about electrical auditing. This is more important subject for current installations. So thank you very much, sir. You have a wonderful flight to Philippines, and all the best for the IEC meeting. So I know whatever that you discuss, that knowledge again shared back to all the participants, and India is going to benefit out of this.
Thank you. Thank you very much, Mr. Dominic, and thanks for all the participants. Let's see you again next month. Thank you very much. Bye-bye.
Thank you, sir. Have a safe flight. Bye-bye. Good day.